Alright, we are going to look at translations of trigonometric graphs. Now a translation is when we move the graph right, left, up, down, or both. So we have specific names for those. So we call a phase shift, a phase shift is a horizontal translation. This is when we move the graph right or left, and then we have a vertical shift, and this is a vertical translation when we move the graph up or down. And then the midline of a graph is the line y equals k, which we're going to find out what k is in a minute. This is the line around which the graph oscillates. Okay, so we're going to have our trig equations in this basic form, y equals a, and then the trig function. In this case, I'm going to write sine of b times theta, or the angle, minus h, in parentheses, and then plus k. So a is still our amplitude, or how high and low the graph goes to reach its hills or valleys. B is going to help us find our period. So let's see, helps find period, and that period is going to equal 360 degrees over the absolute value of b, or 2 pi over the absolute value of b. H is our phase shift, or how much we're moving the graph left or right, and because it's minus h inside the function, that means we're going to take the opposite sign of whatever it gives us here. So if h is negative, or if we have a minus a number inside the parentheses, it's going to be a positive phase shift. If it's plus a number in the parentheses, it's going to be a negative phase shift. So then k is equal to our vertical shift, and that's how far we go up or down. Okay, let's go ahead and do a couple of examples. So we want to state the amplitude, period, phase shift, and vertical shift for each function, and then we want to graph the function. So let's start with our amplitude. There's no number written in front of sine, so that number is a 1. So our amplitude is equal to 1. And then our period is going to equal either 360 divided by the absolute value of b, or 2 pi divided by the absolute value of b. Since they're giving us numbers in terms of degrees, we're going to use the 360 number instead of 2 pi. So, and then b should be the number in front of the parentheses, which there is no number there, so again we assume that's a 1. So we do, 360 divided by the absolute value of 1, which that's supposed to be a 1, not, yeah, whatever. So that is going to equal 360 degrees. Okay, let's find our phase shift. And our phase shift comes from the number inside the parentheses. It gives us theta minus 90 degrees. So again, we change that sign. So our phase shift is a positive 90 degrees. So we're going to be moving our graph to the right 90. And then finally, our vertical shift. that comes from the number being added or subtracted from the total trig function. Now there is no number over here, so that vertical shift is going to be 0. So we're actually not going to move this up or down on this particular graph. Okay, so here's that information that they were asking for, and now we're going to graph this. Okay, so I like to break up the graph into 4 parts because there's 4 important points on sine graphs. Now I'm going to graph the function before the phase shift and then after the phase shift. So I'm going to do that with a dotted line. Let's see. So the amplitude is 1, so it's going to go up 1 and down 1. And the period is 360 degrees, so that's our 4th little tick mark. That's how far it's going to go to complete its cycle. So a sine curve starts at 0, 0. It's going to go up to the top at the first tick mark. It's going to go down to the x-axis at the second, down to -1 at the third, up to 360 at the 4th. Okay, so that would be the graph of sine of theta. We want to move each point 90 degrees to the right. So in this case, each tick mark is actually worth 90 degrees because 360 divided by 4 is 90. So we're going to shift each of these important points, here, 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 well I guess there's 5 important points, to the right 90 degrees. So I'm going to add another tick mark, and then we're going to go ahead and shift those. So this point will shift 90 degrees to the right, so that'll come right here, and then the height will come here, and then the midline will go there, and then we go down here, and then up here. And that's going to continue forever and ever. So the red line is our actual sine graph. Alright, let's do another one. Okay, this time we're going to graph cosine. We want to use the same instructions as the last problem. So first let's find the amplitude. That's going to come from the number in front of the trig function, so that is going to be 1/2. That's how high or low it's going to go to get to the hills and valleys. And then let's do the period. And that is going to equal the number in front of the parentheses inside the trig function. Now there is no parentheses, so the only thing inside cosine is theta. And so there's no number written there, so we assume that's 1. And they don't give us a degree or a radian measure, so we can do either one. Let's go ahead and just do this in degrees. So again, we do 360 divided by the absolute value of b, which in this case is 1. That's supposed to be a 1, not a 2. So that is going to equal 360. So that is our period, or how long it takes to complete one cycle. Let's do our phase shift. Now the phase shift again comes from what's inside the parentheses with the trig function. There are no parentheses, so that just tells us that it's theta. So there is no number there, so that means it's just 0. So we're actually not moving this to the right or to the left in this case. And then our vertical shift is going to be the number at the very end, which in this case is -2. So for this trig graph, we're going to be moving the entire graph down 2 units. Alright, so there's our information there that we're going to use to graph the function. Okay, again, I like to draw 4 tick marks. And our period is 360, so that'll be the last tick mark. And when you divide 360 by 4, these are each going up by 90 degrees. Now our vertical shift is -2. So I'm going to go down 2 units and draw a dotted line. That's called the midline. And that's just going to help me, that's the graph that's, or the line around which the graph is going to oscillate. So that's going to help me find those parts. And the amplitude is 1/2, so that means it's going to be going up 1/2 and down 1/2 from -2. So if I draw half marks, this would be 0.5, 1, 1.5, 2, oh, these are all negative, and -2.5. Okay, now we're not moving the graph right or left, so we don't have to worry about shifting it that way. Okay, so cosine curves start on the y-axis. So we're going to go here. At the first tick mark, it's going to go down and meet that midline. And the next tick mark, we're going to go down to the minimum point. And then it's going to come back up to the midline. And then it's going to come to its maximum at the next tick mark. And it's going to complete that, or continue that pattern forever and ever. So that is our graph for our trig function here. Alright, and I don't like that that kind of looks like it too. So, there we go. Okay, let's do one more example. Okay, and this one's probably the most complicated example that we've got here. So first let's find the amplitude, and that comes from a, or the number in front of the trig function. So that is going to be 3. And then the period is going to be either 360 divided by the absolute value of b or 2 pi. Since they give us numbers in terms of pi, we're going to use 2 pi instead of 360. So 2 pi divided by the absolute value of b. Now b is going to be the number in front of the parentheses inside the trig function, which is 2/3. So 2/3. Okay, well the absolute value of 2/3 is 2/3. And when we are dividing by a fraction, we really multiply by the reciprocal. So this will be 2 pi times 3/2. So the 2's are going to cancel and we get 3 pi. So that is our period. Alright, let's look at our phase shift. That is going to come from the number inside the parentheses. It gives us theta minus pi. So our phase shift is going to be positive pi. So we're going to be moving everything to the right pi units. And then lastly, our vertical shift is going to come from the number at the very end, which is 4. So we're going to be moving the graph up 4 units. Okay, let's go ahead and get ready to graph this function. Alright, and since we're moving up 4, let's see, I'm going to go ahead and graph it someone like that, so we have more room up above. Be going up 4, so 1, 2, 3, 4. That is our midline, or what we're going to be oscillating around. And our amplitude is 3, so let's go up 3 more with the tick marks. Okay, so this is a sine curve. So it's going to start at 0, 0 before the phase shift, which in this case is going to be 0, 4 since we're shifting it up 4 units. I'm going to draw my 4 tick marks, and this time the 4th tick mark is 3 pi because that's our period length. That's how far the function is going to go to complete one cycle. So to find what each tick mark is worth, you're going to divide 3 pi by 4, and that is equal to 3/4 pi. You can also think of that as being 0.75 pi if that is better for you. So let's see, in fact I'm going to write it as that decimal. So this is 0.75 pi. This one would be 1.5 pi, and then 2.25 pi, and then that 3 pi. I'm going to move that over a little bit. Okay, so let's go ahead and graph our function before we do the phase shift. So again, we start at 0, 0, or well, in this case 0, 4. First tick mark, we're going to get up to our height. Second tick mark, we're going to go down to our midline. Third tick mark, we go down to our minimum, which, since the amplitude is 3, we go down to +1. And fourth tick mark, we finally come back up to the midline. Alright, let's complete our phase shift. So our phase shift is pi, which means we're going to move each of these important points pi units to the right. So 0, 4 is going to move to the right pi, so that's going to go somewhere behind 0.75 and before 1.5 pi. So I'm going to draw a line right about there, and I'm going to label that as pi. And then again, the tick marks are going up by 0.75. So if I move this point, which happened at 0.75, pi units to the right, we add pi to 0.75. So that's 1.75, and that's going to happen somewhere around here. And then we do the same thing with really each tick mark. We add 0.75. So this next tick mark, if you add 0.75 to 1.5, you're going to get 2.5 pi. And then if we add 0.75 to 2.5, we get 3.25. And if we add pi to our last important point, which was 3 pi, we get 4 pi. Okay, so what we just did here is we added pi to each of the red numbers. So 0.75 plus pi was 1.75, 1.5 plus pi was 2.5, 2.25 plus pi was 3.25, 3 pi plus 4 was 4 pi. Oh, and then 0 plus pi was pi. So now we're going to go ahead and move each of those points. So this point right here is going to move over to the first green tick mark. And then for our next green tick mark, we're going to go up to the maximum. Next tick mark, we're going to go down to the midline. Third tick mark, we're going to go down to our minimum, which is 1. And fourth tick mark, we're going to come back up. And that's going to continue its pattern like so. So that green part is our graph. Okay, let's go ahead and do one more example. Actually, we're going to do a tangent example. Okay, so our amplitude. Now if you remember, the tangent graphs don't have maxes or minimums, so there is no amplitude for tangent. And then the period, the tangent has a slightly different rule for period. That's 180 degrees divided by the absolute value of b. And b is in front of the parentheses inside the tangent function. And there's no number here, so we assume that's 1. So 180 degrees divided by the absolute value of 1 is just 180 degrees. And let's look at the phase shift. Again, that's going to come from inside the trig function. We have theta plus 30 degrees. So that is going to be negative 30 degrees because we changed the sign. So in this case, we're going to be moving back 30 degrees. And then let's look at the vertical shift, which is going to be the number at the end. So we're going to be moving the graph down 2 units. Okay, let's go ahead and draw our graph. Okay, now the tangent function is centered around the point 0, 0. And then it's going to have asymptotes, one on one side of the axis, one on the other side of the axis. And those points are 90 and 90 usually because the period's 180 degrees. So for tangent, really, we've got 2 important tick marks, well 3 technically. One for one asymptote, one for where it crosses the axis, one for another asymptote, and then it's going to repeat that pattern. Now since the period is 180 degrees here, we divide that in 2 to find those 2 numbers, and that is going to be 90 degrees and negative 90 degrees. Okay, and then we're going to repeat the process. We're going to have another tick mark, and then that'll be, let's see, 180 degrees, because that's the period length. And then if we go over 2 more, that'll be 360 degrees. Okay, and we are moving our graph down 2 units. So I'm going to draw that, and then our midline. Okay, so let's go ahead and draw, let's see, our graph. So we're going to be going backward 30 degrees. So instead, let's do green. Instead of being going through 0, 0, we're moving down 2, so that'll be 0, negative 2. And then we're moving back 30 degrees, so that'll be 0, negative 30. So I'm going to draw that there, negative 30 degrees. And then we're going to subtract 30 from each of these tick marks. So 90 minus 30, that'll be 60 degrees. 180 minus 30 will be 150 degrees. 360 minus 30 will be 330 degrees. Oh, and I guess we also need to subtract those. So if we go back 30 degrees from that tick mark, that's about right there, and 30 degrees from that tick mark's about right there. And then I guess we can go back 30 degrees from that tick mark as well. Alright, so we moved everything that way 30 degrees. Okay, so instead of being at 0, 0, we're at 0, negative 30, and then we go down 2. So that's negative 30, negative 2. So we draw our point there. And then our asymptotes are going to happen on those other green lines. And it's right here as well, and right here as well. And at those middle green lines, those are going to go through our midline. Now the tangent graph starts low and then goes up high. So it's going to hug our asymptotes here, go through that point, and then hug the other asymptote going upward. And our graph is going to look something like that. So for the tangent graph, remember that the period you get by doing 180 divided by b, because they repeat the cycle every 180 degrees, usually, unless b is some other number. So on tangent graphs we have three important points. The point where it goes through the midline and then the two asymptotes on either side of those.